So this is just going to be a quick video with some stuff left over from the last couple of lectures. The first thing is just we can describe something called a demand function, which is really just x star. But the idea is that we're going to keep the price of other goods fixed and the price and the income fixed, and then look at the way that x star or potentially h star, either the Walrasian or Hicksian demand, changes as we change price. And so we can just plot this. It's just a recharacterization of the things that we've already constructed. So there's no new objects here. And we're just trying to look at, as we change the prices of a good, how does the demand for that particular good change? So you could think about it as looking like this. We keep the price of y fixed, we keep the income fixed, and we just make x cheaper and cheaper, right? So we're just moving out along these different budget curves. We're increasing, if we start at the first x, the steepest slope, and we move out, that's making x less expensive. You can afford more of it. And then you can see there's a Walrasian demand characterizing each one of these budget sets. And we can then just think of plotting that Walrasian demand for each price, right? So we just pick that quantity of x prime, x double prime, x triple prime, as a function of the price of x. And so that just looks like this, right? As the price of x changes, how do we change the quantity? Now there's an absurdity here, and I to this day do not understand it. But economists insist on putting price on the y-axis and quantity on the x-axis. And it's just the way people do it. Generally, in mathematics, or the physical sciences, or any other time where you're graphing something, the thing that seems like the input variable, the independent variable, goes on the x-axis, and the dependent variable goes on the y-axis. Now here, there isn't really necessarily, when we're going to talk about supply and demand, an obvious input and output. It's an equilibrium notion, so they co-determine one another. The amount of x that's demanded is associated with a particular price that is the amount that creates that demand, right? I mean, we think of these things as being codependent, so it's not as though there's one specific input and one specific output, but still, price does seem in some ways more fundamental than quantity, especially when we're thinking about consumer behavior. But for some reason, our textbook, every economist has always thought, well, let's put price on the y-axis. It's crazy talk, but it's the way we're going to do it to stay consistent with the rest of the profession. So what you can see here is just as you're increasing the price, so that is a movement up along the y-axis, you're decreasing the amount of x that's demanded, right? So as price increases, you're demanding less. So as we go up, the x's move in, which maybe should look like that. I don't know. I get mirror flipped sometimes. So correspondingly, you could think, given a particular value of x, what is the price such that the person would demand that much x, right? So at x triple prime, what is the price such that would clear? And we see that as you want to consume more x, the price of x has to be falling. That's downward sloping. So this is just a graph of x star is a function of pi. We could also talk about the compensated demand curve, which would be a graph of h star with respect to pi. The demand curve is downward sloping. When I say demand curve, and I don't say compensated demand curve, I always mean x star. I will be specific if I'm talking about the compensated demand curve. The demand curve is always downward sloping unless the good is a Giffen good. So that's almost that literally is the definition of a Giffen good, is one in which we have an upward slope to the demand curve. As we increase the price, the amount demanded, the quantity demanded, is increasing. As long as we increase the price and the amount demanded decreases or stays the same, then we would call the demand curve downward sloping, which means that it's a Giffen good, which means that it's not a Giffen good. The compensated demand curve, on the other hand, is always downward sloping, irrespective of what type of good it is. I mean, for every good, every situation, the compensated demand curve is downward sloping. And that's because the uncompensated demand curve, the regular Walrasian demand curve, reflects both an income and a substitution effect. These two effects which while the substitution effect is always negative, the income effect can be both positive and negative, and potentially so positive that it outweighs the negative component of the substitution effect, leading to an overall increase in the consumption of a good when the price has increased. The compensated or Hicksian demand curve, on the other hand, reflects only the substitution effect. And the substitution effect is always negative. And we've already actually seen this result, and that's the law of compensated demand, that when the price goes up, the amount of that good demanded decreases. The second leftover tidbit that I want to talk about before moving on is elasticities. So if we talk about a change in price relative, and we say, when we change the price $1, we buy one less unit of this good, to interpret this is kind of odd, right? Because prices, changing a price by $1, depends a lot on what we're talking about. If you change the price of bubblegum by $1, that's probably going to have a much larger effect, or what we would think of intuitively as an effect, than if I change the price of a yacht by $1, right? Because what matters is not actually a change in price so much as a change in the percentage of the price, a change in the relative size of a price. Second, if we say, oh, this price change caused a 1 unit change in demand, right? I increased the price a little bit and I got a 1 unit change in demand. It depends on the units that we're measuring it in. So if we're talking about gallons of gasoline, or we're talking about barrels of crude oil, there's a tremendous difference, right? A $1 change might have a huge effect on gallons of gasoline and not such a big effect on barrels. Again, what matters is not so much in the relative change, the absolute change of how much is demanded, but rather the relative change, the proportional change in how much is demanded. So large quantities of goods, things that are demarcated in large quantities, are going to change less with small changes in price, and things which are very expensive are going to change less with small changes in price. And so what we really want to do is normalize these changes in price, or the effective changes in price, relative to the absolute size of the demand and the absolute price in terms of whatever demarcation of money and whatever units of currency we're using. So that leads to this idea or definition of an elasticity. So elasticities are just descriptions of changes in demand, but they're just relativized. So instead of being absolute notions, they are relative notions. So they're relative to the size of the demand and to the size of the price. So it's just a slightly more intuitive measure. They're more comparable across different goods. Most commonly, we're going to talk about the demand elasticities for the Walrasian demand function, and it's just the ratio of the percentage change in quantity demanded to the percentage change in price. So what does that mean? On the bottom, you can see that the top, the numerator, is the change in quantity demanded, and on the bottom is the change in quantity change in price. But these are relative to the amount, right? So it's the ratio of the ratio, right? It's the ratio of the relative change and the relative change. And these deltas, the change in x and the change in p, can be thought of as derivatives, right? So if we instead of are looking at if we're looking at the infinitesimal change, right, the limit of this change, we can say that's dx on the top and dp on the bottom, and then we can just multiply the top by the p and the bottom by the x, and so we get that the elasticity is the derivative of the change in x with respect to p times p over x, right? So this times p over x is just a normalizing factor, which says this is the change in demand, right? This is the slope of the demand function, the slope of the demand curve, but relative to the size of the demand curve. Because if we scale things up or down, we don't want to say, oh, there's actually no change, but that's just because we changed the units, right? Or a very small change because we changed units. So it's de-unitifying, right? So the change in demand with respect to a change in price depends on the units of demand and the units of price. And by multiplying through by that, we're just getting rid of units. So this is a unitless measure of a change in demand. We could talk about also the income elasticities or cross-price elasticities, where we look at the change in the demand for I with respect to a change in price J. These are the same idea. We're just trying to get rid of these units. Own price elasticity is always negative unless you have a given good. So if you're increasing the price, then you're always decreasing the amount demanded unless you have a given good. But the size of the elasticity is what matters, not the sign, right? So if it's exactly -1, that means if I change if I have a 1% increase in demand, sorry, a 1% increase in price, I get a 1% decrease in demand. If I get a 10% increase in price, I get a 10% decrease in demand, etc. If it's less than 1, we call this elastic, less than -1. That means that it's, if it's -2 or -3, a 1% change in price has a 2 or 3% change in the relative demand. If it's greater than -1, so between -1 and 0, then I have less than a 1%, less than the entire, I have a less than proportional change in demand. So the bottom line clearly has a typo. It says revenue is maximized by setting the price so that E equals -1, not 1. So the magnitude of E equals 1. And the idea here is that, what do we mean by revenue? We're saying if you're just trying to sell to people and you're trying to maximize how much they buy, you want to, how much you can, the revenue is the price you're selling it to them times how much they buy. You could think about setting that up as a function, as a maximization problem, right? And the first order condition is such that this elasticity is -1. The interpretation here is that if it's less than -1, then if you increase the price by a little bit, you're going to get more than that percentage increase in demand, so it makes up for the fact that you're decreasing the price. If it's less than -1, you could increase the price by a little bit, and you get the same thing, right? So if you have an inelastic good, you can increase the price, right? Because you increase by 1%, but you get more than 1%. You get less than a 1% decrease in sales. Now this is revenue maximizing, not profit maximizing, but it maximizes the revenue. So maybe we'll have a homework question on that, and that can help clarify that idea. All right, I think that's it for this hopefully relatively short video.